Hey Tim, as you know, I'll be coming to Taiwan pretty soon, and one of my one of the things I want to do while I'm there is review traceability with you for our cams. And I figured we would try this to see if you could if it might work better if you had something to refer back to. Um, I know we already went over helmet traceability, and we can do that again when I have another shipment, but I figured this might be a good opportunity to go over cams. So I figured I would just send you a recording of me kind of going through the process of how I review the traceability for cams and everything we receive and just my general process flow. Um, so we can get started here. Let's see, where do I want to go? So I have the Fuko folder just pinned over here, so for quick access. We can go to cam finish good, Fuko batch testing data, and you'll see here I have like a template saved. The first thing I always do when I um, get the traceability from Fuko is I basically just right click, copy, I go into the year, the current month that it is, and then I'll paste it in here wherever I am. And I'll change the name to, as you can see, like the PO that they're sending. And you can see in here I have like the 4 main items that they're sending us, all empty in the template. Um, so, as I'm sure you're aware of, they send us, half strength data, half strength records, 200% inspection records, the process inspection dimension record table, and then the TES 4000 level form. So I have to go through and check all of this before I can release an order on top of the batch testing that we do, that Sierra does, that I'm sure you've had a hand in, and that I do here as well. So this is generally the first thing I do is I like put in this folder so I have somewhere to save everything to, and then I will go to the email from Nancy. It always comes from Nancy so far, at least. Click on the link for the relevant PO, and then it'll bring me to this page with all the documents on here. And what I've recently learned is the easiest way to go about this is to just click, make sure it actually downloads, and then go through and click every file. You might find a better way to do this, but this is just how I've done this so far. So on and so forth. And then what that does, and then from there I just go to downloads, and you can see like 326, 233, 233. These are all the documents that I just downloaded. And then from there you can copy it, or if it's too many files, I like to open up a second file explorer, go to the appropriate folder, and then from there you can kind of just take all this and dump it into here, and then figure out which folder each document needs to go to. Since we're still waiting on the traceability for this most recent one, I have nothing in here yet. We can go over a previous one. Let's see. So this is just the template in March. I don't need this in here. I can delete this a while. Let's see, what is the one I have? 115191. Okay, so well, actually, this is a good point. This is the second thing I like to do after James does his inspection. I copy that table. I bring it into an Excel sheet. So Like this is James's inspection for that same 115191. I just copy this whole table, bring it into an Excel sheet, and then I delete anything that I'm not currently working or that I'm not worried about. Like, for example, I don't inspect or I don't review the traceability for like trekking poles or anything. So I just get rid of that to make it a little cleaner. And then once I have this in here from his email, I set up more columns just for me to keep it straight. So they send us half strength data, the half strength record, 200% inspection, process dimension inspection record, and then the TS 4000 forms. So from there, let me see. I'll go back to Fuko, cam finish good, batch testing 2025, March. What did I say? This was 115191. And what I like to do here is we'll just do one cam. I'll just go through one cam so you get the idea, get the process. But generally what I like to do is open up all of these. Right, so we have these 3 files, and then I add up these numbers because I know this is like the quantities that they put through the half strength tester, on this day, and then these are all like the different things, like they're verifying like the fixture, the load that it's going to, half strength marks, whatever, all these different things. But the biggest thing that I'm looking for is the quantity of cams that have gone through. So I will sum 139, 196, 177. Well, let's actually, what size was that for? That was for a Z4.1. So let's go back here, Z4.1, and that was the half strength record. And I'll do equal 196 plus 137 plus 105, whatever it was. I forget the exact numbers, but you get the idea. And then I'm just using this to make sure that it was actually more than that. Let's say this, just to make the numbers look correct. I'm looking to see that this number here on the half strength record is equal to or greater than the quantity that James inspected. And once it is, I will come up here, highlight it green. That way I know for Z4.1, the half strength record is like having a passing result. That's what we want to see, so that's good. And I'll go through and I'll do that for all the sizes in that folder. So eventually, these will all have numbers and these will all be green, hopefully, right? That's what we want to see. If not, then we have to go back to Fuko and ask for updated traceability, ask for a correction, figure out what's going on. So the half strength record is pretty straightforward, pretty clear. Half strength data would be the next thing, and that's all of these okay with the date next to it. Again, same thing. I usually open up all of these at the same time, but just to be quicker and for the sake of explaining, I'll open up just the one. We'll give it a second to open up. So this will eventually go in the half strength data. Whenever it opens. this was not a great example. I'll open up another one that has more. Oh, whatever. I'll open up a couple. Okay, yeah, this is better examples. So you can see this is on February 14th. It gives the timestamp, the size, and then up here, this is the maximum force, the end force, and then the displacement, or how far it pulled. What I am looking for is the maximum force. So I will pull this down. What I found the easiest way to do is just highlight this row um, and drag down while also looking at this row to make sure it's all like Z4.1, because sometimes halfway through it switches to a different size. So I'm just scanning row C. Oh yeah, see, there you go, it changes. So instead of looking at each and every individual number, I can look down here at what's highlighted and see the min is 256, the max is 258, and there were 196. So there were 196 Z4.1s that were pulled to at least 256 kilograms. So I'll remember that, 196 Z4.1s, and then same, I will do equal 196. And then eventually I'll come around, like I'll do the next document and they might have 200, right? And then it'll add it up and go on, so on and so forth. Same idea until this number is equal to or greater than this number, and when it is, I will highlight a green. That way I know it's good. I know we've half strength tested at least the quantity that is being inspected. This is a little time consuming, and this might be a little more tedious as you are learning the ultimate strength that all of these are, rated to. So my general rule of thumb is like 250 kilograms is roughly 2.5 kN. So I know if I see like 460, this 9 kilonewtons is like the product rating for Z4.4. And you can see Z4.5, this switches up. This is a 10 kN because this is roughly 5 kN for the half strength. It would be best to double check that, and when you go through it the first couple times, just to make sure they're not missing anything. Just trying to think if there's anything else for this. For this order, you can see, let me pull it up. I sent this back to James because I noticed that there was one single cam. Not all cams went to full half strength. You can see I forget where it is. So because not all of them went to half strength, I had them redo, put them through the half strength machine again, just to make sure everything did get pulled to half strength. So yeah, that is that part of this. Again, just making sure that the quantities are either equal to or greater than this. And then if we move on to go back here, do the 200% inspection. Excuse me. Again, usually I open up all of these at once and I just go through and fill out this whole column, but just for today, we'll do just the point one. So this one is a little different. This is, you can see they started off with 512 point ones. And then there was 3 that failed for side plate and axles, 0 that failed all these, 7 that failed for the distal. I'm not sure which one, but we know that like roughly there was something going on with the distal. And I go through and I check. 494 is what was at the end of the inspection, the good ones at the end. And I'll come back, I'll do 494 and then compare it 494. This one should be the exact number. I guess it wouldn't be a problem if they inspected more, but historically this one has been like exact. So that's just what I expect to see. Let me see. Oh no. Here. So yeah, these are all the different defects, the customer, the size, 494, 494, all makes sense. And then the date code that goes on all of these cams as well. So I go through and I make sure that this whole column is filled out, and then move on to the next thing. So the process inspection dimension record table. This should be one file generally, and these up here are all of our critical characteristics. So the things on the drawings that we define to be like absolutely critical and has to be right. And here in Salt Lake, we had our operators do what we called a 5-piece. So they would take 5 pieces from the beginning of the shift and measure all the critical characteristics, kind of how like they're doing it here. And that way, in the beginning of the shift, if we noticed something was out of spec, we would fix it before we started building anything. So this is kind of just like a check to make sure that the process is correct and it's making a part that is in spec. So you can see there are, let's see. So there's some of them where it's only for like a 0, 0.1, and 0.2. So like on a larger size, we won't see this column filled out at all. But what I am looking for here is making sure that there are at least 5 measurements for every column that is relevant for each size. And I'm not necessarily going through and checking every single number to make sure that it's in spec, but I will spot check, right? So I'll check these 5, I'll check these 5, I'll check these 5, I'll check these 5, and then like move on. I kind of count and make sure. So that's actually a little weird. So there's like, you know, there's 10 here, so that's good. And these are all the different days that they did it, right? So there's at least 5 there, 5 there. They measured all of these except for this one. I'm a little unsure why they missed that one for the 0, for a bunch of these actually. But I'm just like I said, spot checking, just maybe not looking at every number, but making sure that they are recording this, they are measuring, they are checking during production. And then I'll move on to the next size, check some of these numbers, make sure they have measured all of the critical characteristics. And as you can see, sometimes it bleeds on to multiple pages. So both of these are 0.1s, and they've just done a bunch of like extra measurements. Um, Go through 0.2, and this is one where I don't put a number in this. This is just like once I've seen that they've measured the appropriate critical characteristics, I'll put I will fill the cell green so I know that's good and we can release it. So yeah, that's another one you're just verifying. And then we get into the TES 4000 form. So there's another one. I double check, it's the right style number, the size, PO, and then the quantity. So I will usually, when I do this, I'll write 494 for 0.1. So that would be over here, 494, and just double check 494. Okay, so that's the right quantity. And this is going to be a lot more tedious the first couple times you go through it. So this has all of the components that we deemed necessary to have raw material certifications for and reports of measurement. What I do for this, I'm just verifying that they have done an inspection, an incoming inspection. So this is their incoming quality checking list, right? So they've done an incoming inspection on these lobes, and here I am checking to make sure that it is the right material. For cams, it's a little tricky because we have some lobes are made out of 2024, some are made out of 6061, some are made out of 775, 7075. And I'm just checking to make sure that the material report is saying the right material. The first couple times you go through this, you'll have to like pull up the drawing and go down to the component tech pack to verify that it is the right material. And this will definitely be the most tedious part of releasing cams and reviewing this traceability. I look at the axle again, make sure that they have done an incoming quality check. And then here, so what I like to do is enable editing. And then I make this bigger so I can read it. And then bring to front. So this is the test certificate for our axles, and I compared this. So rod alloy steel is like what we've always gotten. This this is the same material report that we used to get when we made these here. So I know it's like pretty vague, rod alloy steel, but this is the same thing we've always gotten, so I'm okay with accepting this as it is. I haven't pushed for a more specific like call out. I'm sure we could look at the composition down here and figure out exactly what it is, and it would hopefully line up with our drawing. But for us to do that, it would take all week long to go through this traceability. So this is the report that we've always gotten, so I'm okay with it. And then same thing here. If you were to pull up the axle drawing, you would see we have a hardness call out, and it's usually like 38 to 44. And I see here HRC 4344. So that's in spec, that's good. That's what I'm looking for on this one. And then here again, for every tab there should be an incoming inspection. I'm just verifying that they have done one. Then I go over here, and I know because I've been looking at this stuff for a while, but what I look for is 304, AISI 304, AISI 304, and then these numbers, because they're HRB 90 or below, I know that's our spec. These are all 90 or below. Again, 304, 90 or below. So I know the crossbar is good. I move on next to the thumb swage. Again, they did an inspection report, and I'm looking to see that this says 6061 T6. Again, I know that off the top of my head, but it'll be, you'll have to go through and just verify with the drawing that it is correct. Moving on to the sling, there are two tabs for this. So there's the first tab, which is just the incoming inspection report. And then the more important one is the batch test. So we have our rating of 20 kilonewtons for the slings, and then this is all the test results for that batch. These are all passing, so that's all we need to really look at for that. Handle cable. Loose is the company we've always got it from, even when it was here in Salt Lake City. So there's two things I'm looking for. It's stainless steel, and then the description is 1/8 inch 7x7. For C4, we have two different kinds of cable. It's either 7x7 or 1x19. And I think they're the same diameter. But this is where you would find that. This was where I'm making sure it's stainless steel, 7x7. For Z4, it's a little more tricky because they're all 7x7, but we have 2 or 3 different diameters that we use. And that is critical because the crossbars are all designed around those different diameters. So we need to make sure that this is correct. So yeah, checking the diameter, the braid, and then the material. For the springs, again, inspection reports, music wire. It's all good to me. It's all music wire. Yeah, so that's where I'm just looking for the material here. Go over to the side plate. Again, the same thing I'm looking for here is JSG4313, and then I see it says 301 here, and that's our material call out for this part is a 301. Go over here to the whip test. We have our rating here, and then the results over here. So just compare these two numbers. This is 1349. It's all like 15 and above, so that looks good. Trigger assembly whip test. It's all 250, at least 25 pounds above the rating. That looks good to me. Trigger wire assembly whip test. 100-pound rating, all at least 125 or higher. So looks good to me. It would be good to be familiar with like the failure modes. Excuse me. They're generally pretty consistent, as you can see. We do have, I'm sure you've seen in the appendix, or sorry, failure mode, we do have some failure modes where like if it fails in a certain way, they need to like shut down production and figure out why it failed that way, because that means something has gone wrong with the process. Like, let's see, cable pullout from swage. We have for C4, that is a bigger problem. That should not happen. we have changed our process and added sandblasting for the larger sizes to make sure this does not happen. And for the smaller sizes, we've shown in development that that only happens when there's something wrong with the raw material, something wrong with the process. So if this, like if cable pull out from swage happens, like that's a big red flag. We do not like to see that. So they have to shut down production and figure out what happened. On the other side, we have like desired failure modes. So if it fails in that way, then that's great. Uh, Nothing needs to happen. But this is just like all of the codes that we set up just to make it a little easier. You can go back and compare, like see what CHS means. That is for, let's see, Z4 whip test, CHS, cable out head swage. That basically means the cable has broke inside the swage and there's still some cable in the swage. That's what we want to see. But I would say the most important thing is making sure that the test result is greater than the test rating. And these would all say fail if it was not. So, but it's good to get an idea for how strong these things are. Half strength, this is just their calibration record. So just give this a quick once over. This doesn't really change. So that's just real quick. Move on to the next. Final inspection, this is their internal document. I'm basically looking to make sure that everything says okay. And it always does. So this is another one that's kind of quick. You just scroll down, everything says okay, move on to the next. Batch test, same idea. Make sure that these are, that the test result is greater than the test rating. Maybe take note in your head of the failure mode. So this is cam, fold, slip. That's what we expect to see on a smaller size in 25% retraction. My one comment for this is these TES 4000 forms should be updated soon because test rating according to SCT review, whatever. And then there's text in these boxes that are different based on like the size and the style. So we need to kind of go back and align with Fuko and make sure that these are all the right forms stated in here, because some of them still call out the testing form which we used in-house, which is outdated and we don't want to use anymore. They should be calling out TES 3098 when referring to a test document for cams. Okay, let's see. Yep, these are all above 5. That's great. And then these last 2 pages are just for reference. So don't really need to review anything there. It's just nice to have. So once I go through, I'll go back to the template, just double check 494, 494, 494, and then I'll come over here and check this off. And then once this whole row is green, then I can go in here and I know Z4.1 is approved to ship. So ideally at the end of this review process, this whole block over here is green with a bunch of numbers in here, and then this row is green. Good to go. And then I will turn this to pass. I'll make it black just for clarity, like so. And then change this. as you can see, approved to ship, and then, oops, that's not what I want. And then I will take this, copy this, and reply to James and reply to his inspection report and say, thank you for the inspection report. I'll make a comment based on any notes that he's made, and I will say like something to the effect of see below for dispositions and shipment status. I'm trying to think if there's anything else. I think this is pretty much it for the traceability review. Also, I always did coordinate with Anders because he did the batch testing here. I have taken over that, so whenever you start to take this over, if I'm still batch testing here, then you would just like confirm with me that batch testing has been completed here, and once all of this stuff is good and you've checked it and everything is correct, batch testing at Fuko is good, batch testing with Sierra is good, batch testing with me is good, then we can approve the shipment. Yeah, we need to make sure all those things are in line. Yeah, I think that's everything. I know this is a lot. I know I went through it pretty quick, but I just kind of wanted to give you, a quick once over of the process for how I go through and I release shipment. Yeah, hopefully you can go through and review kind of a previous order, and then we can go over this again once I'm in Taiwan, and I'll be there to answer any questions, and we can work through anything that you might have questions about. But yeah, looking forward to coming to Taiwan and seeing you there. All right, we'll see you soon.